Okay, so that should be recording now. All right, so now if you remember last semester or last term, we started on this topic of probability, and we'll be going through this for the next 4 weeks. Okay, so just a heads up. Again, listen to the video if you need to, but so first 3 weeks are mainly covering the topic. The fourth week will be the SAC. So that means your first SAC is going to be week 4. So we're already on week 1. You've got week 2 and 3 coming up, and then week 4 will be on your SAC. Okay, so that means there's not really a lot of time to waste. So make sure that you are listening and you're writing notes. On that sheet I gave you, please make sure you're writing some notes that I tell you to. Okay. So the first part here we're going to look into is describing your probabilities, and the intention for that is to understand, okay, values that represent certain probabilities, okay, or certain levels of chance. And in able to reach this, we're going to obviously try to be able to identify what a chance experiment is, and also what the other one is a theoretical experiment, and level of chance with a description. Okay, so we're going to start off with just what's a chance experiment. Those are the first main things. Okay, a lot of words there, but don't fret. Okay, so probability is basically the chance of something happening. Okay, the chance of certain events occurring. Okay, you don't have to write every single thing here. Again, this will be available to you all. So the main thing is you need to listen so you understand what I'm talking about. Okay, but if there's something interesting you do want to write, go for it. Okay, so the probability is another word for a chance of something occurring. Generally, in year 10, okay, probability is represented with a number between 0 and 1. Okay, between 0 and 1. So 0 means 0% chance of happening, and 1 means 100% chance happening, or definitely going to happen. So in this example, 0 just means absolutely impossible, or not possible. 1 means it's definitely happening. 0.5, which is a decimal, means it's a 50-50, okay, 50% chance of it happening. We can also describe probability in words, okay. Now, I think last year we talked about Ramia and his chance of buying a sandwich. I don't know if anyone remembers that. It's in the previous videos, you'll see it. But here is a scale that we can use when it comes to using words. So let me say, for example, what is the chance that Marie is going to be wearing socks tomorrow to school? Probably certain. Yeah, you're not going to come to school in those socks. Yeah, so that means certain. What is the chance that it might rain tomorrow? Okay, no one knows, it's Melbourne, so it could be an even chance. Then it could also be likely if you've looked at the weather report, possibly. Okay. What is the chance that maybe Mr. Todio will call in sick tomorrow? Certain. Ooh, impossible. I can't. Okay, I have to be here tomorrow. So impossible. So basically, these words can also describe probabilities. Okay, and you can see where they also fall within the scale. So unlikely is about 0.3. Okay, so if I write that here, unlikely is about 0.3. And even chance is 0.5. Likely is about 0.7. Very likely is like 0.9. Okay, so you guys can see how that works on the scale there. You can fill out the rest of the scale if you want to, but I can see here that very unlikely would be 0.1, unlikely 0.2, just before even chance would be 0.4, and then this would be 0.6 and 0.8. Now, if you wanted to convert these to percentages as well, 0 obviously means 0%, right? Okay, what would 0.1 mean? Anyone know? You know what 0.1? It would be 10%. Oh, yep. What do you think the next one might be? 20%. So 0.2 would be 20%. Okay, and you can keep going all the way till you get to 100%, which would be that one. Okay, 100%. So pretty straightforward. That's our probability scale there. Okay, let's keep going. All right, so just describing some probabilities. What is the probability it will rain tomorrow? Well, we don't actually know unless someone knows the weather tomorrow. Yes? 100%. Okay, so you're certain it will rain. Okay, so based on the weather report. What's the chance that, does anyone here sing? Yeah, Ramia, you sing? Can you give us a sample? I'm kidding. But if you were to enter The Voice, what's the chance of you winning? 0%. So, okay, but I would give you maybe a 10%. Or it could also be PR. If I represented this as a probability scale, 0.1. Okay, just because you never know, you might be the best one there, maybe. Probability that you'll get over 40% in your SAC, which is a pass. Very likely. So are you saying that it is? It's very likely here. 0.9. So 90% chance. Okay, cool. Even though you haven't done the work. I'm kidding. So PR would be, I could call this pass, is going to be 0.9 or also 90%. You call it that too. And the probability that you'll be here at school tomorrow, certain. Okay, good. So, well, true. But I mean, you never know. I'm just going to say 1, okay? Because 1, remember, on the scale means 100% or certain. Or it could also be 100%. But normally what you want to write is the actual decimal numbers. Yeah, guys, they're sort of the best way that we represent these things. So let's keep going. Okay, so that's basically what we learnt about with theoretical. Oh, no, actually, that would be just a review. Okay, let's keep going. So for this part here, what we're trying to learn is what is an experimental probability. Okay, like I mentioned before, experimental probability. Keyword there being experimental. Okay, what that means is you're probably going to have to do something or do a bunch of things to actually try and calculate the chance of something happening. Okay, and you're trying to identify the chance of an experiment event and then come up with some sort of probability formula for it. Okay, let's move on. Okay, so this is the formula it refers to, but basically a experimental probability is basically the probability of an event based on results that you've obtained by doing something. Okay, so you might actually flip a coin 20 times, and then you can figure out what's the experimental probability of getting a heads. Okay, or you might roll a dice 3 times, and then you could say what was the experimental probability of getting an even number. Okay, so basically, when it comes to experimental probability, it's you doing something to figure out what is the probability of that thing happening. Okay, and this is the formula that we refer to. So if it's not in your notes, I would recommend that you write this. Okay, write that in there. So the experimental probability is equal to the number of times the event you want has occurred divided by the number of times you did the event. So for example, I want to roll a dice. Okay, and I'm trying to get a number that is even. So if I roll the dice 3 times, okay, and I get an even number once, that means the probability or the experimental probability of me getting that dice roll, so even number on the dice, okay, because I rolled it 3 times and I got an even number once, the experimental probability is 1/3. And then if you want to, you can actually leave your answer as a fraction, but you can also turn it into a decimal. If you don't know how to do that, use your calculator. So 1 divided by 3, which equals 0.333. Okay. Okay, so just an example. That 1 refers to the number of times that thing that I wanted came up, and then 3 refers to the number of times that I did the test. So I did the test 3 times, and I got an even number once. So that means the experimental probability of me getting an even number is 1/3. Okay. All right. Now, because everybody here does not have a deck of cards, I'm going to do this. We're going to do this as a class together. I would like you guys to. I'm going to pause my recording. So for this example here, a discus thrower has won 7 out of the 10 competitions. So if she's won 7 and she's been in 10, what's the probability of her winning the next comp? 7 out of 10. Okay. And then if you think about the other flip side to that, what's the probability that she won't win? So if there's a 7 in 10 chance to win, okay, so the PR of winning is 7 in 10. PR of not winning would be the opposite of that, which would be 3 out of 10. Okay, because if she has a 7 in 10 chance of winning, the remainder must be 3 out of 10. Okay, that's just an example there. Okay. All right, this might be the second one, and then we'll go straight into the work that we need to do. Okay. Okay. Actually, you know what, guys? I might pause it there. Right, so initially we learnt about experimental probability, where it involves you actually doing something and then calculating the probability of that event occurring. Now, when it comes to theoretical probability, it's slightly different, okay? But we're going to learn how to calculate theoretical probabilities, mainly of just equally likely outcomes, okay? And then also understand what is a complementary event. We had a look at what that might be in the previous lesson, although I didn't explicitly say complementary, okay? But think of complementary as opposite, okay? And as a success criteria, we're going to try and identify the chance experiment of an event occurring and applying experimental as well, which we've done previously, and then apply it to a complementary rule. Okay, let's move on. So think of a theoretical probability, okay, as something that where you've already gotten the results of something, okay, and you try to actually come up with the probability of it. So someone's already done the thing, but so you're looking at the numbers and you're trying to come up with your own probability for it. Experimental probability is, remember, you doing the thing and then coming up with a probability. Theoretical probability is looking at numbers that are already there, okay, and then you try to make a probability out of it, okay. So it's based basically on theory rather than results. Okay, so it's a little bit different. So here, the formula is sort of the same. Okay, just a slight difference, but here, the probability for theoretical probability, or the formula for it, is here. So the number of favorable outcomes divided by the number of possible outcomes. So the number of favorable means what you want, or the thing that you're aiming for, divided by the number of all the possible outcomes. So let's say, for example, I want to select a random event here. I want to, let's say, for example, there's 21 of you guys here. So say there's 21, so all the possible outcomes, 21, and I want to select a girl in this class. So if there is 21 people and I don't know how many girls, I think there's 12 girls here, 12 girls. Okay, so the probability of me picking a girl is going to be 12 out of 21. Okay, that was just a guess. I don't know if it's 12 girls. And then obviously the opposite of that would be the boys, which would be 9 out of 21. So that's a complementary, the opposite. But basically, similar formula. Okay, so number of favorable outcomes, whatever it is you're aiming for that you want, divided by the number of all the possible outcomes in that trial. Okay. So I don't know if anybody still has there, but we're going to revisit our events. Let's come up with some new ones for this one. Let's see. I'm going to pause. We won't do our random selector, but let's think about the event that we want. Okay. I'm going to go with the probability of getting a, let's go PR of a 4. Okay. Now, if you think about this, this is slightly different to doing the experiment, because you can actually look at it now and actually calculate what that event, or the chance of getting that event. So if I wanted to ask you guys, all right, what's the chance of me getting a 4 in this deck? Think about, does anyone know how many cards there are in a deck? 52, good. So that means, what is the chance of getting a 4? 4 out of 52, because I know there's 4 of the 4s, yeah? Okay. Does anybody else have a different event? What was your name, sir? Eamon, what was your event? You said spades, right? So Eamon said PR of spades. don't need to do the experiment because you can look at the actual outcomes here. What's the chance of you getting a spade, Eamon? Do you know how many spades there are in the deck? 13. Yeah, there's 13. So that means his chance of getting a spade is 13 out of 52. Now, the difference between this and what we did here, okay, as you can see, is we actually went and did the trials, okay, and we got our probabilities. Whereas here, we don't need to do the trials because we can actually examine everything there already and come up with our own theoretical probabilities. Now, remember, when you get a fraction like this, you simplify it, yeah? 1 out of 13, this is 1 out of 4. Or you can also make them into a decimal. So 1 out of 13, I don't know what that is as a decimal, but again, use your calculator if you want to. So 1 divided by 13, which is 0.76. So we'll make that to 3 decimals. So 0.076. Actually, I should round that. Hey, 77. Okay, and then 1/4 will be 0.25. Okay, so make sure that when it comes to fractions that you actually simplify it. And also, as you can see with theoretical probability, you don't need to do the experiment. It's already done for you. All you have to do is look at the event that you want and what's the chance of it happening in the grand scheme of all the possible outcomes that you have. Okay, so here's an example. What is the probability of rolling a 4 in the dice? Well, we know that the probability of getting a 4, okay, you only have 1 4 and there's 6 dice, yeah? So in this case, 4, okay, is the outcome that you want. So PR 4, because there's only 1 4 in the dice. Number of possible outcomes is 6. So remember your formula. So it's going to be, let's call this theoretical. Handwriting is so bad. Theo. So theoretical probability is going to be favorable outcomes. Favorable. Divided by possible outcomes. So total outcomes or number of possible outcomes. I'm just rewriting it so you guys know. It's basically this. Okay. So in this case, probability of getting 4, I know that there's only one chance of getting 4, and there are 6 numbers on the dice. So it's 1 out of 6. Okay, really easy. You can make that a decimal if you wanted to. Okay, now the flip side of this is the opposite of not, or the opposite of 4 is obviously not 4. This is what we call a complementary. So when it's not, it's basically meaning the opposite. Okay? So complementary event is basically the opposite of what it is that you want. So if, for example, let's go to Eamon's example here. Probability of getting spades. What's the opposite of a spade? So if you have 4 suits, heart, diamond, club, spade, and he wants the spade, what's the opposite of getting a spade? And diamonds and hearts. Yeah? So think of complementary as the opposite of what you want. Okay? So, with this in mind, what's the probability of not rolling a 4? Okay, so the opposite of 4. Now, if you, whenever it comes to probabilities and representing them, this means probability of 4. Okay, has anyone seen this before? With a dash on top. Okay, not 4. It means opposite, yeah? So that means PR of not 4. So whenever you see this, okay, dash.
Isn't that dash in the graph there?
Generally, yes, but for now we'll leave it at that. Okay, we'll come back to that later, just so it doesn't confuse anybody. Okay, so probability of not 4. Depends if you have more than one event too. Okay, so in this case, probability of not getting a 4, I'll just go of not 4 for now, so people don't get confused. Okay, so I know that there's going to be one 4 in there. Okay, but because I want the opposite of not a 4, it's going to be 5 out of the 6. Okay, 5 out of the 6, not 4. And what you notice as well is when you look at the event and its complementary, they always add up to 1. Okay, so desired event, think of this as desired event plus the complementary, okay, is always going to equal 1 when you add them together. Because if you think about it as adding them, if you have like all of the events that you want plus all of the events that you don't want, it makes it as like a 100%. That's everything. Okay, so just remember that. Desired event plus the complementary event, put them together, will always equal 1. All right, let's keep going. Okay, let's move on from there. So now this is when you're right in saying when you have more than one event occurring now, this is where you put the line inside, okay? So if we call the outcome we want to be A, so let's say, for example, I just want to call my event A. The opposite of A is going to be A dash. Okay, this is known as a complement of A. So if we have the desired event, so this is the desired event, the opposite of that is the complementary, which looks like this. So you have the dash inside the bracket. Okay. So for example, in this example here, probability of rolling a 4 is 1 over 6. So 1 over 6. And the probability of not rolling a 4 is going to be 5 over 6. Now remember when I said when you add them together, so 1 over 6 plus 5 over 6, it will equal 1. Okay? All right. I won't go through that, but let's go through this. So a card is drawn from a 52 deck playing cards. Determine the probability of drawing a spade and not drawing a spade. So this is actually very similar to his example before. Now this is a little bit tricky, okay, because there's formulas involved with probability, but you can work this out without having to use a formula, okay? So in a deck of cards, you know that there's going to be 4 suits. Remember that, yeah? And there's 13 of each of the suits. Okay, 13 of each suit. So I know this is working out here, but I will probably do it again so you guys can see. So PR, let's go question A. So what's the probability of drawing a spade? Okay, so PR of spade, I think spade is this one, right? Or is this clubs? I'll just use the word spade. So the probability of getting a spade, we know is 13 out of 52, but you can simplify that as 1 over 4. Okay, so that means if the probability of getting a spade is 1 over 4, okay, the probability of not spade, which would be this, okay, will be equal to 1 take away the probability of the spade. So this is using a little bit of algebra, okay, but don't get scared of it. Basically what that's saying is probability of getting a spade, not spade, is equal to 1. So all of it, take away the chance of getting a spade. So in this case, it's going to be 1 take away 1 over 4, which equals 3 over 4. Because remember, the probability of spade, so the desired event, plus this guy, is going to equal 1. All right? All right, let's move on. Hopefully that made sense. Okay, cool. That's basically it for that. So just really quickly, complementary, okay, means opposite. Okay, don't forget that. Okay, difference between experimental and theoretical. So experimental, basically you do the trials, okay, and then you make a probability out of that. Theoretical, okay, means you've already got the results and you make a probability out of that. Okay, without using a calculator, really quickly, which of the following probabilities is larger? A half or 5/8? Anyone know? Half or 5/8? Which one's bigger?
5/8.
Good, 5/8, because that's more than half, isn't it? Okay, so it is greater. Okay, just some final things. All right, cool. I'm going to stop that there.